find all the angles of the triangle, and because we have all the sides of the triangle, we needed to use the law of cosines, which the formula is c squared equals a squared plus b squared minus 2ab times the cosine of gamma. After we converted the numbers we got from being feet and inches to feet with decimals and plugged it into the equation, we got 279.17 equals 171.17 plus 112.01 minus 276.93 times the cosine of gamma. You then would subtract 283.18 from both sides. After that, you'd get negative 4.01 equals negative 276.93 times cosine. Divide both sides by negative 276.93 and you get the cosine of gamma equals negative 0.01. You then take the inverse of the cosine on your calculator, which gives you the cosine, the angle of the cosine to equal 90.83. Now that we have found the measure of angle gamma and we know the length of side C, we can now use this with the law of sines to find out the measure of the other angles. We will first find the measure of angle beta, so we will put the sine of gamma, which is 90.83, over the side length of C, which is 16.7083, and put that equal to the sine of beta over 10.53, which is the length of side B. You then want to divide both sides by 16.083 and solve the rest using your calculator. To find the measure of angle beta, you would need to use the inverse function. To find the angle measure of angle alpha, you take 180 and subtract the angle measure of the angle of beta plus the angle measure of gamma. This equals 49.87. To find the area of a triangle, you take 1/2 times the side A times side B times the side of angle C or angle gamma. After plugging these numbers in, you'd get 69.23 inches squared.
For part 2, we were given side A and side C and angle alpha. So we used law of sines to find the angle of gamma. So to do that, we did sine of 55 over 22 equal to sine gamma over 25. We cross multiplied and divided by 22 to get sine of gamma, which was 68.57 degrees. Then we did 180 minus the sum of 55 plus 68.57, which equals 56.43. Because the numbers we were given was for side-side angle, that means this is an ambiguous case. So to find the second angle of angle gamma, we had to do 180 minus 68.57 to get 111.43 degrees for the second triangle. Next, to confirm that there are two triangles, we did 111.43 plus 55, and that equals 166.43. 166.43 is less than 180, so that's how we know that there are two triangles. To find side B of both triangles, we use the law of sines. For triangle A, we did sine 55 over 22 equals sine 56 over B. We cross multiplied and divided to get that the side B equals 22.38. To find angle beta, we did 180 minus 166.43, and that equals 13.57. To get side B of triangle B, we did law of sines again. So we did sine 55 over 22 equals sine 111.43 over B. Then we cross multiplied and divided to get that B equals 25. Last but not least, we had to find the area of triangle A and triangle B using the formula area equals 1/2 times side A times side B times side of angle C or gamma. For triangle A, we plugged in the numbers and we got that the area equals 229.14 units squared. For triangle B, we did the same thing by plugging in the numbers to the formula and getting that the area equals 64.52 units squared.